We're going to do something very interesting today. We're going to learn to use or abuse the Windows API by calling the rectangle function, which is an API function, a Windows API function that allows you to set pixels and draw over your running application or applications. So you can use that function to draw over running games, or you can draw stuff over your running web browser. So the first thing that comes to mind is, for example, if you're playing a game, you can just draw your own crosshair in the middle of the screen so you can aim better. That would be one application, but of course there are thousands more. You can print frame rates to the screen, over and overlay other applications and do stuff like that. Whatever you can think of, and this is quite a nice function to, well, abuse. This is really it is really not intended to be used that way, but it can be used that way. So let's have a look. First we need a new file and include the windows.h header. Then we need the, just for logging purposes, the standard IO.header, the standard IO header, and I don't think we need anything else. We will see later. And then we need a main method, and I will save that file to, let's call it rect.c. So this is now our function. Let's just print a log drawing rectangle over, or drawing pixels over screen. And let's see if we can compile that in here. So first of all, I need a Windows compiler. I'm going to use this MingW32 GCC compiler. This is needed because I am running all of this in the Windows WSL, which allows me to develop Windows applications, Linux applications in Windows, but I'm now developing a Windows application. Yeah. Okay, but never mind. I use this environment often, so that's why. Then we're going to compile that rect.c to an output file rect.exe, and I'm going to copy it immediately after the compilation to, well, I'm going to copy rect.exe to mount C drive executables. So this is a folder where I store my compiled binaries. It's right here. So let's just execute that, and the window closes immediately. Why? Because we are just printing a log. We would see the result of this probably if I call the Windows command shell and execute it here. Yeah. So this is the drawing pixels over screen output. But of course, this is not going to stay a simple console application. We will now find out how to use the rectangle. So the rectangle function draws a rectangle. The rectangle is outlined by using the current pen and filled by using the current brush. Okay, those are probably two new concepts we have to find out. So let's just create a call for that rectangle. Rectangle. Then the first parameter is a handle to the device context. Then let's just look up how to get a handle to the device context. Windows API get handle to the device context. Get device context handle. The getDC function retrieves a handle to a device context. Yeah, so that sounds promising. For the client area of a specified window or for the entire screen. Of course, we want to use the entire screen. I would like to draw pixels over the entire screen. You can use the returned handle in subsequent GDI functions to draw in the device context. GDI is, by the way, what does it stand for? I don't know. It's the Windows library for graphical user interfaces. So as far as I know, pretty much all of the graphical user interfaces you see in Windows are based on Windows GDI. And we're misusing that by drawing pixels directly to the desktop screen. So we can use this function getDC, and we pass a HWND. That's a handle to the window whose device context is to be retrieved. If this value is null, getDC retrieves the DC for the device context for the entire screen. Yeah, so we can just call that getDC. getDC, and we can just pass null, and this will get or return a device context for the entire screen. So let's call the return value screenDC, and we can pass that to the rectangle function screenDC. And aside from that, let's have a look what the other parameters are. There is a left, top, right, and bottom parameter. The left is the x-coordinate of the upper left corner, top is the y-coordinate of the upper left corner, etc. So let's just draw x 100, 100, down to whatever, 400, 400. That should suffice. We don't really need to figure out anything specific here. I just want to see a rectangle being drawn over the screen. And this should be well enough. So if the function succeeds, the return value is non-zero. So let's also check if the function succeeds. Or how do we do that? We need some... also the getDC function returns a screenDC, and we need to define the type, of course. So this is an HDC, handle device context. Then the rectangle function returns a non-zero value. Yeah, we could do error handling now. Maybe let's just leave it out for now. I will just assume that it works. In a real application, you would have to check if there's an error. And if something doesn't work, we will introduce error handling as well. Okay. Now, I assume that if I just call this, let's go over to the compiler. Let's compile it and see what happens. Undefined reference to imp rectangle, and I have seen this error before. This error happens when you have to link the GDI library, because the Windows or MingW32 compiler by default links just a couple of Windows libraries, but not all. And we have to link the GDI32, I think. Let's see if that works. Okay, so I just appended this flag right here. Then let's open the executable. Oh, and as you can see, I executed it and we get a couple of white pixels here. And yeah, they are, of course, this rectangle is now only partially drawn, because depending on what we do on the screen, it is overridden again. So if I click, for example, on this window right here and move it, then part of the rectangle vanishes. So this is interesting. And this is also one of the reasons why this API method is discouraged to be used. So you should not use it in production environments, but we're going to misuse it and hack our way into achieving what we want. So we are drawing the rectangle right here. I'm also a bit surprised that this already works or partially works. Because the API definition says the rectangle is outlined by using the current pen and filled by using the current brush. It might... Wait, let me just pull up an explanation here, or what I think would be the explanation. So for example, in Paint. Right now we're in Paint. When I draw a rectangle, something like this happens. And the default color is white. Okay? But by changing the color of the pen and maybe the thickness, I don't know where to do that here, or maybe the style of the pen, I can draw a different rectangle, as you can see. Okay, so this is a similar concept in the Windows GDI library. You can select a pen, you can define a pen, and then call graphics functions, and then that pen will affect how those graphics functions execute. So I would actually like to test that pen stuff. So let's just look up in Windows GDI current pen functions. Create pen, create set DC pen color, sets the current device context pen color. This might be something we need. Yeah, so this function sets the current device context pen color to the specified color value. If the device cannot represent the specified color value, the color is set to the nearest physical color. Okay, good. So we will set the DC pen color. Let's do that here. Let's do that here. Set DC pen color. And we pass the current device context, screen DC, the device context of the entire screen. And what else? The color. Let's just see quickly how a color is defined in Windows 32. We have a couple of color constants that we can use. RGB red. And for sure, there's also a way to define those colors yourself. Yeah, of course, you can. It looks like the colors are just a long hexadecimal number, and you can just use a color picker for hexadecimal numbers and just pick a color, for example, let's say this one, and then you can get the hex value here and then pass that here. That would be my understanding. Let's just see if that works. Of course, I have to replace the hashtag with the 0x for the C code to understand that this is a hexadecimal number. So let's just see. It compiled. Let's see if we can get that color. Yeah, the rectangle vanishes. And this is something interesting. I can see the rectangle in my OBS recording software right now, but it's not shown on the screen. So this is really, really hacky. Yeah, so something doesn't work. Right. Okay, why does the picked color not work? The color here is prepended by 2 zeros. Maybe this makes a difference. This is probably the alpha value, which defines the opacity. Let's just see. Okay, there's a rectangle on the recording again. It seems to not work the way I thought it would work. This is a German documentation. Sorry for that. Let's just look up. Where can I change the language here? Here. Okay. Yeah, the color ref value has the following hexadecimal form: 0x0, 0, blue, blue, green, green, red, red. The low order byte contains a value for the relative intensity. Okay. So I would think that we can just use something like that. Let's just copy that and see. But I don't see anything wrong with my color there, actually. Let's just see what happens. Now the rectangle is still... Okay, the rectangle is still being drawn, but only partially, and it's white. So it seems something is still not properly working. Set DC pen color sets the current device context pen color to the specified color value. If the device cannot represent the specified color value, the color is set to the nearest physical color. Okay, so we set the pen color. What about the brush? Because in the getDC function, in the rectangle function, the documentation says the rectangle is outlined by using the current pen. It is outlined by using the current pen. This is just the outline. So maybe that's why we don't see it. Maybe the outline has a thickness of 0 or just 1 pixel. So let me just show it to you here. First of all, let's just get a regular outline. So we are drawing a rectangle, which is filled. And the outline is the outer part of that rectangle, for example, like this. But maybe the outline is set to a pixel width of 0, so we don't see it. And the fill is still white. And apparently, the pen is used for the outline and the current brush is used for the fill. So let's have a look at how to define a brush. Windows 32 brush. Using brushes. Windows GDI maybe. Windows GDI set brush. Okay, there are a couple of functions. Yeah, let's just use set DC brush color. That would be the equivalent of the set DC pen color that we just used. And yeah, it's got the same method prototype, or well, except the method name, of course. So let's just try that. So instead of, or after setting the pen color, let's just also set the device context brush color. And let's see if that creates a colored rectangle. There's the compiled executable, and we still have a white rectangle. Why is that? So we are compiling the rectangle.c and we are outputting a rectangle.exe, and we are copying it to the executables directory, which is this one. Okay, this is not working. Also, the rectangle is not really persistent, so let's put it in a while true loop. And let's compile again and see what happens. Okay, now at least the rectangle is persistent, which is good, but it is still white. So how do we actually color this thing? If the function, we could check the return values of those function calls, of course. We are setting the new brush color. If the function succeeds, the return value specifies the previous device context brush color as a color ref value. Color ref is something we just looked up, which is one of those constants, except I used it wrongly. So let's explicitly use this RGB macro to create a color ref structure. Yeah, let's just try that. So I'm going over here and I'm going to do RGB and I'm going to use 0. Wait. How do we define the values in there? We have RGB. I would like to have a, let's say, red rectangle. Red is the intensity of the red color, of course, but which data type is that? It is not even specified. Okay, it is. The intensity for each argument is in the range 0 through 255. So let's just pass 255, 0, 0. And let's do the same here, RGB, 255, 0, 0. And let's see what happens if I compile that and pull up the executable and execute. It's still a white rectangle. Why? I mean, I'm setting the device context pen color and I'm setting the brush color to the same RGB value, and this is definitely not white. Interesting. Yeah, this is always quite interesting. I'm trying to record the simplest possible videos where nothing can go wrong, and we go off in the depths of some API to find out why something is not working. But this is real software development. So if you enjoy that, then please already leave a like. Anyways, okay. Using filled shapes. Let's just see this documentation. Filled shapes. Okay. This is way too complex. Okay, back to the basics. The rectangle function draws a rectangle. The rectangle is outlined by using the current pen and filled by using the current brush, which is exactly what we're doing right here. Rectangle? Yeah. So what's wrong? The current position is neither used nor updated by rectangle. The rectangle that is drawn excludes the bottom and right edges. Okay, these are just properties or details about the pen movement. If a PS null pen is used, whatever that is, the dimensions of the rectangle are 1 pixel less in height and 1 pixel less in width. Okay, yeah, sure. But this is such a simple function. I'm just passing the device context, and then I would like to set the brush and the pen, set which I'm doing there. So why is it not changing the color? Should I update the colors before retrieving the device context? This would not make sense actually to me. Yeah. This is not the explanation. So let's look again at the brush functions and what we have available there. Set DC brush color sets the current device context brush color. It sets the current device context brush color. Do we even have a brush? So maybe we are setting a color on a brush that is not initialized yet. Set DC brush color function sets the current device context brush color to the specified color value. If the device cannot, represent the specified color value, the color is set to the nearest physical color. And the parameter is the new brush color, obviously. The function returns the device context brush color even if the stock brush DC brush is not selected in the DC. However, this will not be used in drawing operations until the stock DC brush is selected in the device context. Do we have to select a brush first? Wait. What is this function? Get stock object. Nah. No. Okay, let's see if we can select a brush. Windows GDI select brush. And site is microsoft.com. I just want to look at official documentation. Okay, using brushes. You can use a brush to paint the interior of virtually any shape by using a graphics device interface function. Okay, which we are doing. This includes the interiors of rectangles, ellipses, polygons, and paths. Depending on the requirement of your application, you can use a solid brush of a specified color, a stock brush, a hatch brush, or a pattern brush. So this is a documentation that contains code samples, and we have already been here. But let's just check if there are any suspicious function calls in here. Create pattern brush. Okay, it seems that there is a custom brush created in the device context. Create pattern brush. Maybe we have to create a brush. Create solid brush. I just want one color. Create solid brush. We've already been there. The create solid brush function creates a logical brush that has the specified solid color. Okay. But on which context? It creates a brush and we have to only specify the color. And we get a return value, which is the handle to that brush. But then how do we use that brush? Let's look at the code example again. So here a handle to a brush is created. And the rectangle function is used with the device context. Okay. No, I was skipping one line of code. The select object method was used. And the example code passes the device context and the brush handle. So this might be necessary to specify that this brush is being used. The select object function selects an object into the specified device context. The new object replaces the previous object of the same type. Yeah, this is probably what we need. I'm always curious on how engineers or software engineers think of those, of this kind of architecture. This is not straightforward, but there must be a reason for having to select a brush before being able to use it. Why can't I just specify it? And no idea. Okay. There must be some reason. I don't know it. I don't care right now. So let's just do the following. We call the device context. We get the device context here. Then we select. No, first we create a solid brush. I think it was done like that. And we need to pass the color 25500. Like this. Let's just, I don't think we need to change the colors now because we have already initialized the brush here. So let's, after creating the solid brush, it returns a brush handle. And we need to specify the data type of that brush handle as well. So where is that being done? HBrush. Which data type is it? HBrush. Of course, it's just HBrush. And then after creating the solid brush, we have to call select object on the screen device context, and we have to select the HBrush. And let's see if that is what we want. Yeah, and this is our rectangle. That's awesome. And as you can see, if this rectangle is just drawn and drawn over and over again over the screen. And if I just move this window right here, you can see sometimes this rectangle is flickering. And this is because we basically hacked the rectangle on top of the screen. Normally, Windows is heavily based on Windows, right? So all the graphics are done in Windows. And when you just set individual pixels, they conflict with all the windows and the refreshing screen drawings of all the windows. And so the rectangle is partially deleted when it is needed. But since we are looping in a while loop over this rectangle, it is created over and over again, which is funny. So let's just see if we can we do any graphics using this? We could, for example, do whatever. Let's just introduce a variable int move that is 0, and then we increment it in this while loop. Then we increment the x coordinate of the top left corner plus move, and we increment the x coordinate of the bottom right corner plus move. And this should give us a moving rectangle actually, but probably it's moving off the screen too fast. But let's just see. It's going to move too fast because the while loop is not delayed using a sleep function. So it's going to pass very quickly. Yeah. Wait, let me just terminate the old running application here. Yeah. And let's call a new rectangle axle. Oh. It's not moving fast. Did I compile it? Ah, there's an error in the compilation. Where's the error? Error screen DC is undeclared. But didn't it just compile already? This compiles. But this doesn't. No, it did compile now. Well, I have no idea why. So let's call the rectangle executable. And we don't see any rectangles. Why? Maybe, because I just called it from the command line. Let's double click. Yeah, okay, that's the expected result. The rectangle moves off the screen so quickly that we don't see it. So let's just introduce a delay. Standard, what was it called? No, UniSTD. I think this is a Unix standard or something like that. Or universal standard, no idea. But this library, this header contains a definition for a sleep function, which we can use sleep, and this use sleep, and this defines a microsecond delay. So let's redraw the rectangle every, let's say, 1000 microseconds, which is once every millisecond, I think. And let's save that and go back here. And let's execute. This was still way too fast. What happens if I... Let's see. I'm just putting a very large number here. This is 100,000 microseconds, so this should be 0.1 seconds. Let's see how that looks like. No, something is wrong. No, I'm stupid. Oh my god. You probably have seen it already. I'm incrementing the move inside the while, inside these while brackets. However, move is 0 initially, so while won't even enter because while 0 is going to evaluate 2 false, and so this while loop is being skipped. So let's execute it properly now. Okay, as you can see, we have a moving rectangle now. It's moving very slowly and it's very laggy because we are not redrawing it quickly enough. We're just redrawing it once or 10 times a second. So let's just reduce this sleep function wait time and compile again. And let me just also call this again. Oh, and now we have the second rectangle here. So probably we have to terminate the first rectangle. Let's erase that and let's execute. Yeah, this is way too slow. Come on, go faster. Use sleep. Let's do 1000. Let's compile that and execute. Yeah, this is faster. It can still go much faster. For example, 500. It can still go faster. 100. Why is it so slow? But as you can see, the rectangle is already working. It's just being drawn over what we already have, which is the funny part. Why is it so slow? Maybe the drawing time is already not very fast in and of itself. So the sleep function doesn't add significant delay. Yeah. So cannot create regular file permission because I am running the application, I can't of course override it, so that's why we didn't, or the application did not copy over to the target directory. So let's execute it now. It's still not very fast. Let's remove the use sleep and see how fast it goes at maximum speed. This is the maximum speed. Interesting. Okay, but what if we just increment the move value to, or if we increment the move by 2, move incremented by 2. Let's see. I mean, at this point, we're just playing around with the code. Yeah, this is faster. And as you can see, the old rectangles persist, which is quite interesting. We can probably delete the old rectangles explicitly somehow. So this is very, very buggy. Let's have a look at if we have to delete the old rectangles, or if we can delete the old rectangles. So where's the executing thing? Here. Okay. So rectangle, Windows GDI, delete rectangle. Maybe we have to free it. Create or remove GDI shapes on command. You can't change the color of an, yeah, of course, I can't change the color of an already drawn image, but I can redraw it. Yes, of course. Using rectangles. Maybe there's a free function somewhere here. Release device context. No. Oh, okay, there's an offset rectangle function that we can use. There's even an intersect rectangle functions that we can use to intersect two rectangles. But this is not what I want to do. Actually, we have already shown that we can move the rectangles. Let's do something more interesting. Something for the gamers. Let's create a crosshair in the middle of the screen and overlay it, use it to overlay whatever you're doing. So the middle of my screen, I've got a full HD screen. So it's 920 divided by 2 by 180 divided by 2 would be the y coordinate. This would be the center of my screen. And 920 divided by 2, 1080 divided by 2. So this would be setting an individual pixel at the very center of the screen. Let me just confirm that. I can't see it, maybe because the width of that pixel is 0. So let's just create a define width, and width is equal to, let's say, 5 pixels. And let's work in the width right here. This is the line width. Then we define a height. The height would be whatever, 50 pixels, for example. Let's specify width to be the line width, and then a general width of the crosshair we want to draw at the middle of the screen, which is also 50. Or actually, we don't need it. We just need a height. We can just do width equals height. So this is going to be minus line width divided by 2, and the x-coordinate of the bottom right corner is also going to be incremented by line width divided by 2, and then the y-coordinate is going to be decremented by height divided by 2, and the y-coordinate of the bottom right corner is also going to be incremented by the height divided by 2. Let's compile it and see what it looks like. Yes, and we have a line at the center of the screen, and it's overlaying whatever application we are running. Let me just make this a bit bigger, just for the demonstration, but you can, of course, use as fine a line as you need. So let's just make the line width 20, the height, let's make it 100 and see how that looks like. And let me execute it. Yeah, so this is my crosshair at the middle of the screen. Is it even called crosshair? Crosshair. Yeah, crosshair. Okay. Maybe a line width of 20 is too much. Let's do 16. And yeah. Then we need to draw another rectangle. That is going to be the other cross section of the rectangle. So we have to adapt the x-coordinates and, of course, the y-coordinates. Line width, just like that. And let's execute and see. And as you can see now, we've got a nice thick crosshair at the center of the screen, and it is drawn over anything. So we can just open up any game. I don't have a good example right now. What is a simple online shooter, for example? Simple online shooter. First person shooter, whatever. I don't really want to pull up a game now, but you get the point. You can you can walk around in your game and support your own aim using this crosshair, which is quite nice. Of course, these values look a bit hard-coded now, so we can also define the display width and height here. For sure, I guarantee there's a method, or there are methods that retrieve your screen dimensions, but let me just keep it very simple. I just want a hacky solution here. So let me introduce the screen width. In my case, it's 1920, and the screen height is 1080. And then in those calls down here, I can replace. How was that being done? I can replace 1920 with screen width. And I can replace 1080 with screen height. Yeah, it looks much better now. As you can see, we don't have any hard-coded constants here. We only have defined them up here in the macro section. So and maybe one thing I would like to adapt just for more visual impact here. Just for the sake of this video, let's increase the size of the crosshair. And let's compile and see how it looks like. Of course, I have to terminate the first application first, otherwise they are drawn over each other. And let's execute. Yeah, I have to first terminate the application and then override it with the new compiled binary, otherwise the permissions are denied. Yeah, now I have a big crosshair which is drawn over the screen at all times. So what else can we do? Let's make it even bigger. Permissions are denied. Yeah. Okay. And that is pretty much it. If you enjoyed this video, this was just a very hacky exploration of how to draw stuff on the screen raw without any, well, how do I phrase it? Without using the APIs as they were originally intended by the manufacturers of the operating system. We just misused the API to draw stuff to the screen directly for our own satisfaction and our own needs. And right now we have this beautiful application which we can use to draw a big fat crosshair on top of the screen. Of course, you can also adapt this to be a small fine one for your gaming needs or whatever. And even if you're not a gamer, this is quite nice. It's quite cool to just print stuff on the screen. And maybe you can even do some animations here and there. We've seen that there are library functions to move the drawn rectangles and to intersect them properly and do all these kinds of things. But of course, the scope of this video has to be limited. So this is our result now. I hope you found this exploration entertaining. And just to emphasize this for everybody who jumped forward in the video, this crosshair is overlaying any application you are using, as you can see. So it's always drawn on top of the screen, regardless of what you're doing. Let me just pull up a calculator, for example, for better aim in the calculator app. Yeah, so feel free to experiment with that, and let's see you next time. Bye.